Well, it's yet another lesson. My name is Tumsima Cohen, geography teacher. For this particular lesson, I pray that you be with me, you understand everything, and feel at home. I always talk about hope to my students. Please have hope. Today, we are in O-level, Geography Paper 2. 273/2, Geography Paper 2. And we are in the segment of Rest of Africa. I know many of you, Senior 3, Senior 4, you also have a paper called Geography Paper 1. This is Geography Paper 2. And for this particular one, we are in the Rest of Africa. And I'm introducing a brand new topic, which is not so new to you, but this time around at a broad length. And that is the characteristics and factors affecting climate of Africa. These words are also unique to us. For example, characteristics. These are attributes or qualities of something. Factors. It may also be referred to as reasons why something happens the way it is. Climate. This is our guest today or tonight, whatever you may wish to call it. Then Africa. Of course, Africa is one of the continents of the world. Of course, the oldest continent. It is a huge raised plateau. And of course, many of you used to refer to it as a dark continent, but who tells you it's not a dark continent? You only knew less about it. So let's not waste any moment. Let's start immediately by talking about climate. Before I talk about climate, I know in your primary level of education, you studied about weather. Actually, if you go back to nursery, many of you could talk about weather. You could be like, today is windy. You dance, today is windy, today is windy. Some days it would rain, and you say, today it is raining. Some days, today it is chilly. I've even seen most of you saying, I'm chilling. It is a chilly weather. But what is weather, first of all? So, we are starting on that note. Before we go to climate, we must know about weather. And many of you used to define it in primary. Even here, we're going to define it today as the day-to-day condition of a place recorded over a short period of time. But today, I'm going to add some unique words in it. Allow me writing on the blackboard here and expound more on it. I'll use these words. Weather refers to the atmospheric. I'm going to talk about it, don't worry. Atmospheric conditions of a place. I guess we are together, of a place, measured and recorded over a short period of time. I know somebody is wondering, why is the teacher starting with weather, yet the topic is about climate? Don't worry. We are going to see how climate comes in, because climate is some big aspect, is bigger than weather. But to go to climate, you must go through weather. So, I'm defining for you weather as the atmospheric pressure. Somebody is asking himself or herself, what is atmosphere? Briefly, look at my drawing. I've drawn a simple circular shape of the earth. But if you move from the earth 500 to 1,000 kilometers. 500 to 1,000 kilometers. The thin layer of air is called the atmosphere. Now, this atmosphere we live in is full of gases which react to bring about different conditions, what you're calling weather. But what you note very carefully here is that weather is an atmospheric condition of a place measured and recorded over a short period of time. Let me hope it together. We can now move on. Weather can be described in the following ways. Let me put it for you here very fast. Weather can be described as one, somebody may say, raining. Well, rain is part of what we call precipitation, where water droplets come from up to the earthly surface. So raining is one of the conditions or the elements of weather. It may rain in form of showers, where rain comes like you shower in your room, there in your bathroom. Rain can come in form of drizzles, like from morning up to evening. Rain can come in form of snow. The other way you can describe it is windy. Windy. Wind is the air blowing over the land. It can also be described as cloudy. You wake up in the morning, you see clouds all over the whole day. It can also be described as sunny. You wake up from morning, you see the sun up to evening. You say it has been sunny. You can also say foggy. Foggy. You wake up in the morning, you see fog. Some of you confuse fog with mist. They are all similar. Their similarity is the difference. Let me not confuse you more. But when you are jogging in the morning, if you look closely to your head here, you will see some droplets of water on your hair. Or you can wake up in the morning and you don't even see any tree outside. And you start wondering, that will be fog. And that's how you can describe weather of a place. Let's go on. We have what we call elements of weather. In the previous episode, we were looking at how weather can be described. But now we're looking at the real elements of weather, where we have our rainy conditions, where we have our mist, where we have our fog, where we have our cloudy conditions. And one of them is clouds. If you recall, we talked about cloud, and cloud is coming from these clouds. Clouds are of different types. We also have what we call air temperature. Air temperature, which we define as the coldness or hotness of a place or a body. Then we also have what we call air moisture. Air moisture. When you see over here the word moisture, it is all about the water content. Then we have atmospheric pressure. All these are similar. Atmospheric pressure. This is to do with warmness, coldness, etc. Then we have humidity. Humidity. It can be high or low. When the humidity is high, you receive heavy rains. When the humidity is low, you receive very little rainfall. So it means that humidity is also all about water content or water vapor in the atmosphere. Then we also have the wind speed and direction. wind, speed, and direction. So those are the elements of weather, where we get our description of weather from. Now, it is high time we look at our guests officially. We can look at our guests officially, and that is climate. Now, we said weather is the day-to-day condition, but now climate is a long-term summary of the weather conditions. When I say long-term, what do I mean? I'm talking about 30 to 35 years. Weather applies to a place. For example, let me say, Najanangumbi. Let me say, Padibe in Gulu. Let me say, Kabuyasoke in Masini. Let me say, Mpologuma. Let me say, Manafa in Bali. Let me say, Soweto in Masaka. Let me say, Kimombasa. I understand from Mombasa and I'm very happy. Well, that's good, but that is weather, and weather is covering a very small part. But when it comes to climate, you keep on adding atmospheric conditions from day 1 up to 30. I know many of you are 10 years. Is there anybody who's 10 years? Nobody. I know many of you are 17, 18, 30. There's somebody repeating there, but it's okay. Now, for climate, you must add the atmospheric conditions for over 30 years to come up with a climate of the region. Let nobody deceive you that the climate of today is bad. That is not good. But you can say that today's weather is chilly. Today's weather is windy. But you can say the climate of East Africa, because East Africa is a big area and it's been long that these conditions have been added and the averages have been got. So we can have these simple notes as wait for your notes, and I can define for you climate. Climate, I say, refers to the average weather condition of a place or region. You can even say country, as long as the area is very wide. Recorded, let's have this measured, and recorded. You have to measure, then you record for future references because it's a long term. Recorded over a long period of time, usually 30 to 35 years. I've said climate refers to the average weather condition of a place or a region, or you can say a country, measured and recorded over a long period of time, usually 30 to 35 years. But you can get a question in an exam where they can say, differentiate between climate and weather. It can come even in geography, or one, or here. Let me put it for you here. Food for thought. Let me put a single question for you here. Distinguish. The word distinguish is the same as differentiate. Distinguish between weather and climate. And I can put for you in brackets here 4 marks and say, oh my God, we learned about it. So it's a matter of saying weather is the day-to-day condition of a place. measured and recorded over a small period of time, while some of you like using the word whereas. Climate is the average weather condition of a place, measured and recorded over a long period of time. If you miss it out, it's up to you, you lose it all. But why do you miss out the word a long period of time? Usually 30 to 5 years. Very good. Now let's move on. The climatic figures of Africa have been closely studied for a long period of time, and some findings have been discovered that the climate of Africa is grouped into 6 broad categories, as you're going to see. When we look at these categories critically, climatic types in Africa, I've said they've been studied and grouped into 6. Now, I think I've done this for you. If you critically look at my map of Africa here, I've drawn it with my hands, and I can also try it at home there in your free time. If you critically look at it very well, we have 6 different categories of climate, as I'm going to note them for you in the blackboard here. And one of them is the first type. Let me put number 1. Equatorial climate. The word equatorial, if you look at it very well, it is derived from the word equator. I know when you're in primary, you could say about the equator. They could say, what is the line? They could even put the word imaginary line. Drawn on a map, marked 0 degrees. You could all say, Medija, equator. Very correct. They even give you flowers. Flowers. Do you still have some flowers you give me? Don't give me, please. Well, equator, equatorial. Then, the second type is tropical, number 2. I'm putting a tick because some of you like XTICS. I'm even putting number 2 because we want 2 things. You want 2 places at school. I'm saying. Number 2 is tropical. But there are some people who say, oh, savannah. I've even seen some students who are old, they even have babies now. They call themselves savannah. Some are musicians. They even come on stage, they say, let's invite savannah on stage. I asked myself, are these musicians or climatic types? But I think they were just inspired by this topic, climate. Number 3, by the way, this tropical or savanna climate covers the biggest part of Africa. As you see on my map here, there is a part on my map which has stars, and it is almost the biggest part of my map, and that is tropical or savanna. Thank you. The third type is Mediterranean. That word is spelling. Mediterranean. But don't be scared. Mediterranean. Yeah, for me it's simple. Mediterranean. M-E-D. I have my pointer. Let me point. Let me point. Mediterranean. M-E-D-I-T-E-R-R-A-N-E-A-N. Mediterranean climate. It is found in the extreme parts of Africa, around the Cape Ranges, around the Atlas Mountains there. Then the first type is called desert. desert climate. Desert climate. An area where the rainfall is very little, the temperatures are ever hot during the day, at night it's very cold. You see little grass or no grass at all. You see a lot of dust moving, can even cover and kill you. I'm sorry, I know you're scared, but when you go to heaven, oh, you will go, okay? Well, we shall look at all these types, their characteristics, where they are found, and we even draw some statistical graphs. Number 5 is mountain climate. Mountain climate. I know many of you have seen mountains, like the Atlas Mountains, Drakensberg, Fort Jalon, Ethiopian Highlands. Here in East Africa, we have Mountain Rwenzori, Mountain Elgon, among others. The last type is the warm temperate. But some people have given it another name, and that is the high veld climate. So I can say stroke, the high veld climate. So these are the 6 broad groups or categories of Africa's climate, which has been studied critically for a long period of time. You can easily tell that Savannah is stopping here, Equatorial is stopping here. But before I go any further, let me give you a warning. Not a warning of scaring you, a good warning. Never ever confuse climate and vegetation. They may be friends, but for today we are particularly for climate. Let's go on. So we shall have this map, as I've told you already. We shall have this map showing these 6 broad categories. The deserts, for example, you can see the Sahara Desert. You can see the Mid around somewhere here. You can see the Equatorial in the center here. You can see the little mountains of Ethiopia here. You can see the mountain of Cameroon here. And very many others I've left out. But we shall have these in our notes. So let's go on. But before we leave this map, when you closely look at this map of mine critically, you'll discover that there is a line of the equator marked 0 here, which is crossing Africa at almost half. But the part in the northern hemisphere, this upper part is called northern hemisphere. It is the biggest. Then we have the other part also in the southern hemisphere down. Symmetrically, that's a hard word. Let me put in the blackboard, maybe. Let me put this one in the blackboard, then we come back to our map. When you were in your mathematics lessons, you could have such a paper. The teacher could make you, let me use my paper here, the map, real map. Let's go back to our map here. When you look at this map critically, when you divide it halfway like this at the equator, this is what we call a line of symmetry. This middle line I put in the middle here, line of symmetry. When I fold it like this, now you have one part of Africa down and one part of Africa up. Now, this upper part, if you look critically from the equator, we have Equatorial here, followed by Savannah. You are going up, followed by desert. Now, when you move down, you start with Equatorial, Savannah, desert. So it means climatic groups in the northern hemisphere and southern hemisphere are the same virtually. Why? Africa is located in low altitudes of 37 degrees north and 35 degrees south. And this makes Africa the continent mostly located in the tropics, and therefore call it a tropical continent with such kind of characteristics of climate as we've already seen. So, you're a good class for me. Now let's move on. The topic of the characteristics of climate, the characteristics and factors affecting the climate of Africa. Now, we have said that the climate of Africa has been studied and critically categorized into 6 broad groups. And if you recall what happened from the blackboard, our first one was equatorial climate, followed by tropical or savanna, followed by desert climate, followed by mountain climate, followed by high veld or warm temperate. Now, I want to start by looking at the first one in detail, and that is equatorial climate. So, I've told you before that equatorial climate borrows a name from the imaginary line marked 0 degrees, what you call the equator. Some of you have moved in your country, Uganda. You have moved along a road called Kampala-Masaka Highway. When you are going to Masaka, you'll come across a place called Kayabwe. Or some of you come from Kasese. When you are moving from a city called Fort Portal in Kabarole, and you're moving towards the town, you'll come across a place called Kikorongo. At that place, you'll find a big demarcation. They will say the equator. I know some of you, even stop our vehicles. Me, I like putting on a cape, jean trousers, my camera, my headsets. Yeah? Do you have headsets? Don't force your parents to buy your headsets. You take pictures at the equator. But someone was asking, Master, where is the equator line now? I can't see the equator line. No. The equator line is imaginary, but it is there. So that's what we call the word equatorial. And this equatorial climate can best be found in the Congo Basin, and those areas, the Congo forests, bring out clearly what we call equatorial climate. Now, before we continue any further, let's look at the characteristics of equatorial climate. I know somebody is trying to pronounce the word characteristics and it's not coming out. You are biting your tongue. Don't worry. But when I say characteristics, I mean the attributes, the makeup of something. One time I was teaching students and I asked them, tell me some of the characteristics of students in town areas. They told me, 1, they are ever smart. 2, they are big spenders. Meaning that they eat a lot of money. At break they eat 300 shillings. 3, they have nice uniforms. Then I told them, what about the village students? They were like, Master, they don't have shoes. They come with sugar cane. Are you seeing the difference? Now, when it comes to equatorial climatic regions, our first characteristic is that, let me put in the blackboard here, rainfall is heavy is heavy. Usually 1,500 millimeters per annum. The word per annum is the same as per year. That the rain is received in an equatorial region is 1,500 millimeters. By the way, in Uganda here, we also have equatorial climate in areas around Lake Victoria. For example, Wakiso, Mukono, Jinja, Busia, Masaka, up to Tanzania. Now, if you've been very keen, if you've gone these areas, the rains received there are extremely heavy. Point number two, rainfall is distributed throughout the year. This rainfall which is heavy, the rainfall is distributed throughout the year. You receive rainfall from January up to December. I've had some even seen from December to January. But it's true. We receive rain from January, February, March, April, May, June. Even when the rain is stopping in June slightly, some days the rain is gone. Meaning that the rainfall received in the equatorial climate, 1, is heavy, 2, it is received throughout the year. Number 3, there are 2 rainfall peaks. We shall draw a bar graph, and we shall discover that on our bar length graph, we shall have bars. We shall have bars drawn, and well shaded. But when you look at rainfall in equatorial regions, you'll discover that around April and May, the rainfall is very heavy. That's one peak. In June, July, the rains go down slightly. In November, I know many of you enjoy grasshoppers. November, October, the rains go high again. Meaning that equatorial type of climate has got 2 rainfall peaks. Then next, rainfall is mainly convectional. We shall have all these notes. We will say there are 2 rainfall peaks. Then I've said that the rainfall received in equatorial climate, rainfall is mainly convectional. Somebody is wondering, what is convectional rainfall? Convectional rainfall is the type of rainfall experienced around large water bodies and dense or thick rainforests. If you go to the Congo Basin, the neighbor to Uganda, neighbor to Rwanda, those areas have been huge rivers like River Congo, one of the biggest rivers in the whole world, River Congo. You will discover that they experience rainfall in the afternoon, and that type of rainfall is called convectional. Someone's again asking there, seeing him or her, Pastor, why do these areas receive heavy rainfall if they have dense forests and large water bodies? This is because these water bodies and the tropical rainforests experience what we call evapotranspiration. Transpiration is the process through which plants lose water to the atmosphere. Then evaporation, as plants are losing this water, it will evaporate. That's why I'm saying I'm cutting the one word, then evapo. Let me cut like this. Evapo, I put a hyphen, transpiration, evapo, transpiration. Transpiration. I'm joining two processes. Transpiration, where plants are losing water in the atmosphere. Evaporation, a process through which it is being transported up to the atmosphere. When this vapor moves the atmosphere, it reaches a point called saturation level or condensation level, where it condenses, comes too heavy, too cold, and falls in form of rainfall. But this rainfall is normally received in the afternoon, so we call it convectional rainfall. Now, this very point of convectional rainfall can put a comma, and we say it is accompanied with, I'm using classic English, it is accompanied with, I know some of you are saying by, but for me I'm saying with. They will get me later. They will thank me later or get me later? Thank me later. Accompanied with thunder and lightning. I've said that this convectional rainfall, which is received in equatorial climatic regions around large water bodies and thick forests, is received in the afternoons, and it is accompanied with thunder and lightning. Now, what is thunder? Thunder is that loud voice you hear when it's raining. Don't be scared, please. I'm not Al-Shabaab, okay? Well, this type of rainfall will have thunder, that loud voice. Bah! If you're weak, you can easily faint. Then you will see some light. But between the thunder and lightning, the light comes the faster, because some of you are doing physics. You say light travels faster than sound. True or false? Of course, true. Now, once you see the light, don't be scared. You have not died. But if you're dead, you won't even know. Maybe your ghost will know. But please don't die. So be careful about the thunder and lightning. Then also, we have what we call the temperatures are hot. Temperatures are hot. Please don't say hi. I repeat, don't say hi. How many times have I said it? Twice. I've said, don't say hi. You say temperatures are hot. I've seen some people in equatorial regions like Congo forests, like even here in Uganda, Wakiso, afternoon, they are busy learning lessons with papers, they don't have AC, they are sweating in the taxi. Why? Temperatures are hot. Not only hot, they are hot and evenly distributed throughout the year. I'm going to give you a table here. You will discover that in January we have maybe 30 degrees centigrade, February 28, April 29, May 30, June 31, July 28. Almost the one even is well distributed. Another climatic condition for equatorial type of climate is the diurnal temperature range. The word is here. The diurnal. This word diurnal. Let me use the point again. The word is diurnal. Let me underline it with a ruler. I have underlined the word diurnal because I know many of you don't know it. The word is simple. It means daily or day to day, for today. So when you get the coldest temperature of the day in the morning at 6, and you get the hottest temperature of the day between 3 and 5 p.m., you subtract it, you will get a very small range of about 7 degrees centigrade. So I'll say diurnal temperature range. Diurnal temperature range. Let me remember to use this word. Diurnal temperature range is small, about 7 degrees centigrade. The word range means the hottest minus the coldest. You get the biggest, subtract the smallest. You get what we call a range. Okay, let's go on. Another characteristic of equatorial climate is that there is a high relative humidity, that the water content in the atmosphere is very high in equatorial regions, and is that humidity responsible for the heavy rains. Second last, it has got a dense, some of you like saying, thick cloud cover. Someone was asking me, Master, why are you saying dense? Do you mean that even clouds get F9? I said, no. The word dense means thick. You see a thick cloud, you even start seeing darkness during daytime. You say, you want, Mom, it's night already. No. The world not coming to an end. It is only a dense cloud cover. Then lastly, low pressure all year round. Low pressure all year round. The word low pressure means that these areas around the equatorial climate are always warm, and areas which are warm will always attract the cold, moisturized winds to that area. So we say these areas of equatorial have a low pressure all year round. Okay? Now, leaving that aside, okay, we are still looking at equatorial climate. I have told you already that equatorial climate is most found in areas of the Congo Basin, Cameroon there, moving up to areas of Nigeria briefly. You come back to Congo Basin, some part of, let me leave out Uganda, because we're looking at the rest of Africa. Now, I have talked about the characteristics of the equatorial climate, one by one. Now, I want to give you an example of a table which has been recorded, that is temperature and rainfall. We can draw a bar and line graph together right now. So this is our table. I can copy it from the blackboard here. Let me copy this table on the blackboard. Example of a station. Example of a station with an with an equatorial climate. So our table is like this. We can even call it station A. Don't ask the teacher, where was this station? Let's hide it. Station A. It has got month. Our table has got temperature. Temperature, of course, in degrees centigrade, labeled in brackets. Our table also has got rainfall. And rainfall is in units of millimeters, not millibars, but millimeters. So I can draw my table with my ruler. I guess you also have a ruler. I can draw my table very smartly here. Of course, I like smart things. So this is my table. As you can see, I'm drawing it here on the blackboard. So this is my table. Now after drawing this, you can see here the 3 lines. 1, 2, 3. Month, temperature, rainfall. The temperature is in degrees centigrade, rainfall is in millimeters. Now let me put the month. January, Feb, March, April, May, June, July, August, September, October, November, December. Then I can close my table. I can close my table here. Very well. Very well. Very well. I've closed my table. So you can complete your table very well. 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 Very well drawn table. I know many of you have heard of the word statistics. We are now in the part of statistics. When they say statistics, they don't mean something from heaven. No. They mean dealing with figures. 1, 2, 3, 4, 5, 6, 7, 11, 12, 100, 120. 150, 1,000, among others. So, when you look at my table very well, I have, for temperature, I have 23 for January, 23 for February, 23 for March, then April and May, 22, 22, even June, by the way, 22. Now let me look at July. Let me look at July. July is also 22. August is 21. What about okay. July is 21. July is 21. August is 22. September is 22. October is 22, November is 22, and December with your big days is 23. This is what I talked about in the other notes of the equatorial climate. That temperatures are hot throughout the year. You can see 23, 23, 23, 22, 22, 22, 21, 22, 22, 22, 22, 23. Throughout the year. It is hot. Okay? Now let's look at rainfall for this particular station. And we have 40 for January. We have 70 for February. We have 150 for March. 150 for March. We have 230 for April. We have 205 for May. We have 115 for June, followed by 65 for July, followed by 80 for August, followed by 195 for September, followed by 225 for October, followed by 150 for November, and 50 for December. Now when you look at December critically, the rainfall reduces, most especially after receiving the grasshoppers. The rainfall is reduced. Now if you look at this December, we have 50 millimeters only. So this is a typical example of an area with equatorial type of climate. Now, one day you will sit for an examination. All the things you learn in class with your teacher, like I've been teaching you from climate and weather. I even gave you a question, distinguish weather and climate. I even gave you the answer, but I don't even copy the notes. Now, you will go in a newspaper and you see this kind of table drawn, and you say, I have ever seen such a table. It has marked temperature, rainfall. I have ever seen it. Then, after seeing it, they will say, Citadel, the information in the table above. In the table above. And answer the questions that follow. And they will say, question number A. Draw a bar and line graph. Draw a bar and line graph showing the climate or situation A. Then you say, oh my God, I'm going to pass with 100% because I know what to do. So what do we do? Having seen such a question, you don't need to rush. You just ask the invigilator. Somebody giving the exam. Excuse me, sir. May I have a graph paper? May I have a graph paper? This graph paper will have your name up. It will have some many green lines. But if you look at this graph paper, it has a box. And if you get a ruler very well, you get your ruler and measure, you will discover that each one box is 1 centimeter. 1 centimeter. But now, when we are going to draw our bar and line graphs, we follow some steps. And for today, I want to do them practically with you here on the blackboard. We see if you can cope up. But the first thing I've said, we use a graph paper. I have seen some stubborn students who want to use other types of papers. That because for them they are very smart, they are tall and they eat very well. Who tells you? Take away your eating very well. You must not use this kind of papers, but you must use a graph paper. Very good. Now you can come with me to the blackboard here. The good thing in the question they have told us, draw a bar and line graph showing. But sometimes they can say, using any statistical method of your choice. Let me repeat. Using any statistical method of your choice. represent the information in the table above. And let me give you a secret. Let me whisper to you a secret. Once you see such a table, think about a bar and line graph. And the first thing you do, you come with your graph paper on the table there. You come. You put a title. You put a title. You say a bar and line graph showing the climate, of station A. On your graph paper here, that title is written up here, after your names, your initials, index number, 0020, you put here up a bar and line graph showing the climate of station X. Very well. Now, members, I want us to be very serious here. When you look at this page, oh people of mine, the graph paper, we are going to balance it. We want to put our graph down here. Why are we here in this part here? We won't put the graph this side, not this side, but this center here. We are going to use at least 3/4 of this graph paper. After, you will leave some 2 centimeters this side, maybe on your left or your right. You leave some centimeters in the margins. For what? For labeling. Labeling. You even leave some space down for labeling, so you balance. So for instance, you can come here on your graph. I assume my graph is here. I put my long ruler. I can balance 3/4 of the page and measure 20 centimeters. 20 centimeters. I can come down here. I've left some space here for labeling. I'm also leaving some space down here for labeling the man. Let me create some more space. So I've left space here. I've also left some space here for labeling. For the space up here, I've said I'm going to I have measured here roughly 20 centimeters. Roughly 20 for better planning. Because our graph has got rainfall, which is going to be the first one down here. Then up, we are going to put temperature. That's why I've at least put here 20 centimeters to avoid overlapping and better planning. And sure, I've left space here, I've left space here. Now, I'm taking my time to put this axis here. I'm going to tell you why. So after doing that, I will come here. I measure from this axis. Let me even put for you 0 here. 0. I'm going to measure 1 centimeter. 1 centimeter. I put January. Another centimeter. Feb. Another centimeter. March. I'm on the horizontal axis. I'm skipping 1 centimeter. I'm measuring 1 centimeter. 1 centimeter. Another centimeter, I put April. Centimeter, I put May. Centimeter, June. Centimeter, July. Centimeter, August, centimeter, September, centimeter, October. I can add on my line here. October, centimeter, November, centimeter, December. Then I come down here and say, these are month of the year. I have labeled, I have used initials, January, February, March, April, May, June, and I have measured, I rather labeled month of the year. My last month is December. Immediately this last part is December, I will come with my ruler, draw the second axis. The axes are now two. The vertical axis, the one that's standing like this, are two. I'm assuming this is my first twin. Maybe I can call her Bavaria. Then I call this one Wasma, the second twin. Now, on my horizontal axis, I have put the month of the year. Now, here is the pattern. We need to get the vertical scale for rainfall first. For me today, I'm going to use this scale. Vertical scale. Vertical scale. Rainfall. I'm going to say 1 centimeter represents. We don't use the dots. We use the word represents 25 millimeters of rainfall. I've not said you also use 25. You can use a choice of your own. You can use a scale of your own choice. I won't dictate. No. For this time, I'll just say, let me use 25. According to me, I'm not you, altogether. Now, if I've used 25, if I look critical in my table here, of rainfall, the biggest figure is around 225. So I can move from 0 and move slightly above 225. So I'll come to my table here. I say here 0. I move 1 centimeter. You must mark. That will be a basis for your scale. You put 25. You are going to put that centimeter. 50, 75, 100, 125, 150, 175, 200, 225. I come here, 250. Now, 250, say this one represents 25 millimeters. Our biggest value of rainfall in the table is 225. But me, I have moved slightly above 225 and I've put 250. Okay? I assume you're also doing it in your graph there. Please follow. You can even pause. You can continue at your own pace. Now, after putting this rainfall, I will say this is rainfall in millimeters. Whatever you do this side, please transfer it this side. 0. You can put your 0 up here. Then you come here. 25, 50. 75, 100. You make sure the rain automatically. 100, 125, 150, 175, 200, 225. Then you come here and move 250. I think they are rhyming. Because they are all twins, they were born on one day. They are all rhyming. Are they not rhyming? So, you will come here and put rainfall in millimeters. So both sides have rainfall. Now, before we move to the aspect of temperature, we can now first plot our rainfall very fast. So we shall come to our table very well. We say, rainfall for January. We got the table, January 40. We move. This is repeated. Now here is the pattern. How do you tell that 40 is here? Yet 40 is not a lot of people here. Now, Master, I'm now confused. Why should you be confused? Here is the magic. Not even the magic, reality. If your 1 centimeter on this graph, 1 centimeter has, let me count for you. 1, 2, 3, 4, 5. 1 centimeter has 5 small divisions, right? So you just say 25 divided by the 5 small divisions. What do you get? I'm good at mathematics. Let me see. If this divided by this, what do I get? You get a calculator out there and press. So if I press very well here, 25 divided by 5, I will discover that for the first 20, I will get for the first 20 divided by 5, I will get 5. Isn't it? Now, what about the other next 5? So it means 25 divided by 5. Each small box will be 5. Now, if I want to get my 40 very well here, what I will do, I will move from here, 0, up to 25. Now, I'm very sure that each box is 5. I will top up plus 5, 30, plus 5, 35, plus 5, 40. Meaning that I will add on 3 divisions. And so I'll just come like this and put my 40. After adding 3 divisions to 25 to make it 40. Now, someone may have used a scale which is different. Maybe 10. 1 centimeter represents 10. So for just said 10 divided by the 5 small divisions, and in this answer will be simple, 2. And you just say, hey, each small division is 2. You keep on adding the 2 until you get your answer. But for me, I've discovered that I'm going to be using 5 after my calculations. So I'll join my bar like this and change immediately, no wasting time. After, I'll go to Feb on my table, Feb 70. I'll come, Feb 175 means I will ignore 1 box, which is 5, to stop at 70. No, here. I will ignore 1. So I'll stop somewhere here. I come and draw. And join here also. And join here also. With a ruler, you must be very neat. Very neat. Then you also shade. We got March. March is 150. We move this March. We put our ruler very fast. March 150. We draw. March 150. We draw. We join here up. Immediately, no wasting time on our graph paper. We also shade uniformly. We got April. April is 230. We come to April. We move 230. 230. This is 225. But since we said each small box is 5, we shall add on the 5. We move up to here. 230. I'm not very accurate because I have a black graph paper here on my blackboard, but still you can get the picture very well. Then I close here the box very well. Then I shade it very well. Oh my God, I'm shading it and it's really nice. I'm not joining the bar, I'm shading each bar independently. Then after doing that, I move on to May. May is 205. 205. 5, right? We move to May. We put our long rule, of course, very fast in working time. We move up, and you see that I have two sides, and the sides are helping me. We move up 205, so I'll add 1. And we join our 5s, and we shade uniformly. So we shall do that repeatedly. We are drawing our bars, we have put 105, we have shaded independently. Remember, we must be impressive. We must shade and embrace the person looking at our work. It must look nice, right? So let's go to June. That's 115. June. 115. This is 100. If you look, you can use any side of your choice. 100. Then on the 100, you can add 3 boxes. That's 15. You can move up to 100 is here. You add 3 more boxes. You draw and you join, of course. You join. You shade uniformly. When you go on and look at July is 65, we move to July, 65. 65, on 50, we are going to add more divisions. That is 55, 1, 60, 2, 65, 3. Up somewhere here, we draw the bar. And we shade uniformly. Then we go to August, that is 80. August 80, that is 75 plus 5, 1 small division. You draw. Up to 80 and you shade. Then we go to September 195. We move 195 September. 195, 195, that's 175. We shall add 3 to make it, 4, 195. Up to here. Then we join our bars. Then we shade also. It must be uniform. October 225, we move. October 225. It's already marked here for us. Then we join here very fast. We join our bar. 275. We include a very nice shading. November 150. November 150. 150 for November. Then lastly, rainfall is 50. And 50, you just come here to December, you're doing your last bar happily. So this is rainfall. As we said earlier on in our notes, that for an equatorial type of climate, we shall have 2 rainfall peaks, and surely they come out very well. It means we are correct. Then, as we wind up this segment, after this part for rainfall, we shall skip. Let me try to expand my line here. We shall skip a centimeter and we draw a zero line, what we call a freezing point, and we also mark it 0. Now we are crossing to temperature. So we can even mark this as a freezing point. We mark it with a 0. Now we are adding temperature. Temperature, we shall say 1 centimeter represents, now for my case here, I'm going to use 10. You can use your own choice, your own scale. If you look at these figures very well, the biggest is around 23. We are going to use 10, so I can say 1 here, 10, 20, 30. Then I say this is temperature in degrees centigrade. I come this side. Since they are both twins, I even put here 10, 20, 30. I say temperature in degrees centigrade. Now, we are almost coming to an end of our graph. For temperature, we are going to plot like this. If it is January, please watch critically here. If it's January, we are going to come in the middle of January like this. January is 23. We are going to move in the middle of 23 for January up to 23. Each is 3. I mean 5. So it means each small box is 2. So for 23, we shall move. 23 we shall move in the first division, then approximately in the second. Then we plot in the middle. February is also 23. We shall move in the middle of January here, the midpoint, don't forget about that. We also plot 23. March, still 23. We shall come in the middle of March and plot 23 because of the line. We move to April, 22. April is slightly down. 22. We move down 22. May is 22. July is 22. So for May, 22. July, 22. August, no rather, July 21. July is slightly down, 21. No, this is 22 for June. July is 21, slightly down. August is 22. August is 22, slightly up. But in the middle, September, October, November, all 22. September is also 22. 22. October is also 22. November is also 22. December is 23. In the middle, 23. In the middle. So, conclusively, we come with our pencil and we join these dots for temperature using a free hand. So I can join here like this, using a free hand, a free hand, a free hand, a free hand, a free hand. I can leave it hanging or I can even join to the axis. And that is my bar and line graph showing the climate of station X. So to summarize the whole lesson, today we have looked at the characteristics and factors affecting the climate of Africa. We've defined weather as a day-to-day condition of a place recorded over a short period of time. We have gone ahead and defined and given some elements of weather like air pressure, air temperature, humidity. We've gone ahead and defined climate as the average weather condition of a place recorded over a long period of time, usually 30 to 35 years. We've gone ahead to categorize the climate of Africa, and we've said it is into 6 groups. where we have had different types like desert climate, mountain climate, equatorial, savanna, warm veld, among others. And today, we have gone ahead to, in detail, look at equatorial climate. We say it's common in the Congo Basin, Cameroon, Nigeria there, on our map of Africa, which I showed you earlier on, and so I'll have it now notes. Then, we look at their characteristics in detail, and we've gone ahead to sample a statistical method of an example of a table, and we finished up here with a bar and line graph, well drawn and well labeled. My name is Tumsime Cohen, your online teacher. It's been a nice time. Please, you can go through this and you get more notes as you'll be directed. Have hope, stay safe. Thank you.